these are questions 11 through 15 for the final exam review. So starting with 11, we're still working with the quadratic formula. However, in this case, we are going to end up with complex answers because the square root is going to end up having a negative number inside of it. So if my a here is 3, my b is -4, my c is 5, I would do x equals -4 plus or minus the square root of -4 squared minus 4 times 3 times 5 all over 2 times 3. So -4 is a +4 plus or minus -4 squared is 16 minus 4 times 3 is 12 times 5 is 60. That's under the square root all over 6, which is 4 plus or minus -44 all over 6. Now 44, here's what we're going to do to it. So for starters, the negative would become an I squared, and I'll be able to pull the I out. The 44, I can split into 4 times 11. So the 4, the square root of 4, comes out as a 2. So this is going to end up looking like 4 plus or minus 2i. Square root of 11 is what's left inside, all over 6. So let me just repeat that. Under here, the -44, I would rewrite as I squared times 4 times 11. If I take the square root of that, square root of I squared is I, square root of 4 is 2. That's how I get the 2i. And then the 11 is left inside. Now I can simplify as long as it comes out of all three terms. So if I reduce by 2's, I end up with 2 plus or minus I square root 11 over 3. Of course, for complex answers, they want you to split the real part from the imaginary part. So you would write this as 2/3 plus or minus square root of 11 over 3i. And that's two answers. 2/3 plus the square root of 11 over 3i, comma, 2/3 minus the square root of 11 over 3i. And that's the answer. Okay, so over here, we're trying to solve an equation that has a square root. So I can undo the square root by squaring it, as long as I also square the other side. So I get 4 equals 3v plus 10. And then I just solve this equation. So I get -6 equals 3v divided by 3, v equals -2. And then what you want to do is you want to double check that the -2 actually works. So 3 times -2 is -6. -6 plus 10 is 4. The square root of 4 is 2. So that is true. Problem number 13, they want us to use the distance formula to find the distance between these 2 points. So I recommend that you label your points. So x and y, x and y. This is my point 1, this is my point 2. So the distance formula is d equals x2, which is -7, minus x1 squared plus y2 minus y1 squared, and that whole thing is in the square root. So that would be -7 minus 0 is -7, squared is +49, and then 3 plus 1 is 4, squared is 16. 49 plus 16 is 65. So square root of 65 is actually my answer. I want to make sure that 65 doesn't reduce. So if I do a factor tree, 5 goes into 65 13 times. These are both prime, and they're not the same as each other. So therefore, I cannot reduce the square root of 65. Number 14 says a line passes through the point -2, 9 and has a slope of -4. Write an equation in slope-intercept form. Slope-intercept form looks like this, y equals mx plus b, for this line. So I would use the point-slope formula, which looks like this. Y minus y1 equals m times x minus x1. This is the point they give me, so I'm just going to call that point 1. I don't have a point 2. And my slope is -4, so that's my m. So I would write y minus 9 equals -4 times x minus -2. And then I would start simplifying. -4 times x plus 2. Then I would probably distribute my 4. So y minus 9 equals -4x minus 8. To get it in slope-intercept form, y needs to be by itself. So I would add 9 to both sides. And I would get y equals -4x plus 1. And that would be the answer. Okay, the last question for this set gave me the equations of 3 lines, and they wanted me to tell them if these lines are the same slope or parallel, or perpendicular, which means that they're, you know, they're like at 90-degree angles of each other, or neither. Okay, and the way we do that is we look at their slopes. So this is already in slope-intercept form, y equals mx plus b. So I know that my slope here is -4. For this line, I don't know that yet, so I'm going to solve it for y. I'm going to do my work right here. So if I subtract 4x, I'll have 16y equals 32 minus 4x. And then if I divide by 16, I get y equals 2 minus 1/4 x. Now, even though the term with x is second, my slope is always the coefficient of the x. So my slope for this line is -1/4. And then for this line, it's easy because they have it in slope-intercept form. Slope is 1/4. So these are my 3 slopes. And I need to compare those to determine whether the lines are parallel, perpendicular, or neither. So lines 1 and 2, so this is 4, this is 1/4. So these are reciprocals of each other. So they're not the same, therefore they're not parallel. They're not perpendicular either because they would have to be opposite signs and reciprocals of each other. So in this case, it's neither. So I'm going to put an N for neither. Lines 2 and 3, they're not the same because this is a -1/4, this is a +1/4. And they're not perpendicular because they're not reciprocals of each other. So this is also neither. Then I would look at 1 and 3. They're opposite signs and they're reciprocals. This is a 4, this is a 1/4. This is a negative, this is a positive. So these 2 lines are perpendicular, and that's the symbol for perpendicular, or you would just, you know, check that box or whatever on your homework screen. All right, I'll talk to you in the next video.